As we start our journey into statistics for this year, we're going to take a moment just to check that the foundations are in place and that we remember everything that we should remember from grade 8 and 9 statistics. Okay, first of all, we're going to look at measures of central tendency, and the three that we look at are the mean, the median, and the mode. So if ever we are asked to work out the mean, what they are essentially asking us to do is to work out the average, and we can write that in a formula. So mean, the symbol for mean that your math teacher probably uses is an X with a bar on top of it, X bar, and what we need to do is we need to add up all of the scores and divide by the number of scores that there were. Okay, so that's a very fancy maths formula, but it's good to kind of get into that habit because we are going to build on some of these symbols. Okay, so let's have a look at it. This here is a capital letter sigma, a Greek letter, and that means sum. So this is just the sum of all of the scores. And then this, n, is the number of scores. The median is the middlemost score. So it divides the data into two equal halves. And what we can do, and what we've probably done in the past, is kind of count our way to the middle by counting the same number of places from the beginning and the same number of places from the end. Very important, your data values need to be in order. But we can also identify the position or the location of the median by saying n plus 1, n again is the number of scores, divided by 2. So that'll tell us in which spot we'll find our median, and then we go and we look for that data value, and that would be the middle marker. Okay, if the middle marker happens to be a fraction, so if you had 5.5, for example, then you would add the score in position 5 to the score in position 6 and divide by 2. Okay, and then finally, the mode. The mode is the value that occurs the most often. So you'll look at your data set and you'll see which score is repeated the most number of times, and that will be the mode. Let's practice. Okay, so here we are given some raw data and we are asked to calculate the mean, the median, and the mode. First up, the mean. So that's X bar is equal to the sum of the scores over the number of scores. So let's figure out how many scores we're dealing with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data values there. Okay, so that's n. N is equal to 15. Helpful to know. And now we want to add all of these values up. So you just pick up your calculator, plus, 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 and once we've got the sum, we can work out the mean. So if I add all of these scores up, I end up with 348 divided by the number of scores, 15. And so we calculate that, and we see the mean is 23,2. Okay, so that's the average of these data scores. Now, the median, we're going to start and we're first going to say, okay, where is it located? So the position of this, there are 15 scores. Remember the formula said, n plus 1 divided by 2. So 15 plus 1 divided by 2, and that makes 16 divided by 2. So it's the 8th data value. Okay, very important is to check that these are in ascending order. If these are not in ascending order, we can't just read the median. We need to first arrange them. But in this instance, they do go from smallest to biggest, so we can jump to this step where we calculate which position. The 8th position is my median, and so the median here is equal to 21. And then finally, the mode. The mode is the score that occurs the most often. So having a look here, I've got 2 12s, 3 21s, and those seem to be my only repetitions. And so this here is definitely going to be the mode. 21 occurs 3 times, and so the mode is 21. Those are our measures of central tendency. Then we need to look at measures of position. Okay, and this is new to our grade 10 syllabus, so we need to pay attention here. So the median divided the data into 2 equal halves. The quartiles divide our data into 4 equal quarters. And once again, we can actually work out the position, just like we did for the median, but now we can work out the position for each quartile and then go and find that data value. So if we want the first quartile, we can say 1/4 times n plus 1. To work out the second quartile, we can say 2/4 times n plus 1. And that, if you were to do a little bit of algebra manipulation, you could see that's actually the same as the formula that we use to work out the median. And that makes sense. The second quartile should actually be the middle marker. So quartile 2 is the same as the median, and then quartile 3 is 3/4 times n plus 1. Okay, and if you put 3 dividers into your data, it will be divided into 4 equal quarters. Okay, and then you get other measures of position, things like percentiles or deciles, and that basically then divides into 100 or into 10. And we can use those for different reasons. Percentiles are actually fairly common, especially when it comes to newborn babies. It's a very helpful measure in terms of tracking whether or not a baby's growth rate is within some degree of a normal range. Percentiles are extremely helpful. Something that's also good to know is that just like we saw here, Q2 is the same as the median, Q1 would be the same as the 25th percentile, Q2 would be the 50th percentile, and Q3 would be the 75th percentile. Okay, so it's about seeing some kind of a bridge between our data and then just being able to interpret it based on what we are working with. Let's have a look at our same data scores now, but what we're going to do this time is we're going to work out the quartiles. So use the raw data scores above to calculate the values of quartile 1, quartile 2, and quartile 3. Remember, quartile 2 is also known as the median. Okay, the first thing that I would do is work out the location of each of these. So let's get our formula ready. We saw just now there were 15 scores here. So n is equal to 15. Okay, so the position of Q1 is going to be 15 plus 1, or 1/4, times 15 plus 1. Okay, and that gives us 4th position. Okay, Q2 is going to be 2/4, or 1/2, times n plus 1. So that's 8th position, and we actually did work that out earlier. And then Q3 is going to be 3/4 times 16. And if we work that out, it takes us to the 12th data value there. So let's identify them in the data set there. Quartile 1 is the 4th data score. Quartile 2 is the 8th data score, and quartile 3 is the 12th data score. Important to note that quartile 1 is not 4, it's the value represented in 4th place. And again, the order from smallest to biggest is super important. Okay, and then helpful to see that it is divided now into 4 equal quarters. 3 scores, 3 scores, 3 scores, and 3 scores. So to finish off this question, Q1 is equal to 14, Q2, same as the median, is equal to 21, and Q3 is equal to 31. Now let's have a look at some of the measures of spread. So range is basically how far our data ranges. Okay, it's not enough to say, oh, this is the smallest number, this is the biggest number. You actually need to calculate it. And so it's the maximum score minus the minimum score, and then you get an answer. Okay, be careful there. Don't give a broad answer, give a mathematical answer. Okay, sometimes there are data values on the extremities, the minimum or the maximum. They are outliers. They are so different from the rest of the data that it's actually not accurate to have the range as your measure of spread, and then you rather use the interquartile range. This is also known as the IQR, interquartile range, and that involves taking quartile 3 minus quartile 1. So basically, the space between the quartiles. And then finally, the semi-interquartile range. Now, semi, like in a semicircle, means half. So that's just going to be half of the interquartile range. And you can just work that out. Divide your interquartile range by 2. Let's practice this. So here's the work we did earlier. We found the quartiles. Now they want us to determine the range and the interquartile range. So let's do that. Range is the maximum minus the minimum. So the highest value here, 47, minus the lowest one, 5. The range is 42. Okay, and then if they asked us for it, the interquartile range, that is Q3 minus Q1. So just the space between quartile 1 and quartile 3. So that's going to be 31 minus 14, which gives us 17. Now, in our studies thus far, we will have encountered what is known as grouped data as well as ungrouped data. So let's have a look at 2 graphs here that one of my students drew. The one, clearly her brother is forever burping during meals, and so she drew a graph that says bar graph, proving that my brother is gross, and she literally documented how many times he burped in any given meal. So on 7 days, he burped twice during a meal. On, let's see, this one here, on 3 separate occasions, he burped 6 times in a meal. Okay, so there's a bar graph. In this instance, you can see the data here is 0, 1, 2. Those are distinct data values. Whereas the same student said, okay, well, let's draw a graph that explains the time it takes to complete my homework, okay? And this could really just flow on. So either between this here in the x-axis, time in minutes, it could be anything from 0 minutes all the way up to 150 minutes, which is a good long time to spend doing homework, 2.5 hours there. Okay, but because things could really flow from the one to the next, she opted to draw this as a histogram. Now, if you take a look at this, both of these sets of data make sense according to the information that they were representing. Okay, so in this instance, single data values, this is ungrouped data. So although it has been organized and it's in a graph like this, it was probably even in a frequency distribution table, but because it's like this, it's ungrouped data, okay? And we need to address that in a specific way, whereas this other histogram here is grouped data. Now, why do I say that? Well, have a look at the x-axis. There are groups of 30 minutes per interval. And because those groups run onto each other, we don't want to have spaces between the bars. That's why you opt to go with a histogram there. Okay, we are going to be expected to know how to work out the mean, median, and mode of both of these types of data, but it is important to know the difference so that you use the right formula when the time comes. Let's end this video with a bit of a challenge. It says here, can you calculate the mean, median, and mode of the data in the graph? Okay, so we've got this graph here about the burps. And so what do we know when we want to calculate the mean? So that's x bar. We want the sum of the scores divided by the number of scores. But the tricky thing here is that this student hasn't given us the raw data scores. So although this is ungrouped data, these are not groups, but there is still some undoing that we need to do in order to interpret this. So there are 2 data scores. If we were to think back to her table, she had to plot 2 occasions where there were 0 burps. 1, 2, 3, 4 occasions where there was 1 burp. And so what we can do is, when we work this out, is we can say 0 plus 0 plus 1, 2, 3, 4 ones, okay? And then divide by the total number of scores. Or we can be a little bit smarter about it and we can do some calculations beforehand. Okay, so what I like to do is I like to say 2 times 0, and that's going to give me an answer there of 0. Then here, 4 times 1, that's going to give me an answer of 4. In the next bar, 7 times 2 gives us an answer of 14. So what I'm doing here is I'm taking all of the scores and I'm just figuring out what would the total be just for the scores represented in this bar. Okay, so we're going to carry on here. There were 5 days when he burped 3 times per meal, so that's 15. There were 6 days where he burped 4 times per meal, so that's 24. Then 4 days with 5 burps, and finally 3 days of 6 burps. Okay, and now it's going to be much easier for me to work out this mean, because what I'm going to do is I'm going to say x bar is equal to 0 plus 4 plus 14 plus 15 plus 24 plus 20 plus 18, and then I need to divide by the total number of scores represented. Okay, let's see. 2 is the frequency here, plus 4, so that's 6. 6 plus 7 gives us 13, plus 5 is 18, plus 6 is 24, plus 4 is 28, and then plus 3 takes us to 31. So this student collected data for an entire month. So if we calculate that, we get 3,06 burps per meal, which realistically you can't have a 0.06 of a burp. So I'm going to round that to a logical 3 burps. Okay, the modal number of burps, that one is actually going to be a lot easier. We just need to look for the highest frequency because that tells us the mode. So there, 7 is the highest, and that was 2 burps per meal. So our mode is going to be 2 per meal. And then the median, let's first work out what is the position of the median. Okay, how many scores have we got? 31. We worked that out. So 31 plus 1 is 32. Divided by 2 means it's the 16th position. And now we just got to be quite crafty in terms of figuring out where does the 16th data score lie. Okay, what we know is 2 lie here, then plus 4, 6 data scores are less than 1. And then if we plus another 7, that takes us to 13. So maybe what I should be doing is keeping track here of this cumulative frequency. So here we had 2 plus 4 is 6, plus 7 is 13, plus another 5 is 18. And we want the 16th position. So we're safe enough to say here in this bar, 3 burps is going to be the median. So the median, 3 burps per meal. And there we have it. A challenging question, but it is possible to do it if you try to understand the data behind the graph.